Hello, today we continue solving problems. And today we are solving problems on concentration, which is expressed in moles of dissolved substance, referred to the volume of the solution in decimeters cubic. So, the first problem, we're given sulfuric acid with a mass of 19 grams. And we're given a volume of solution containing this acid, 400 centimeters cubic. We are asked to find the concentration expressed in moles referred to a decimeter cubic. Note, in order for us to do the calculation, we need, turns out to be not the mass of sulfuric acid, but we need its amount of substance. In order to make this calculation, we need to calculate the mass of paint for sulfuric acid. In this case, recall, we rely on the periodic table and add up, taking into account the indices, the relative atomic masses. If we calculate, hydrogen has 1 times 2, sulfur has 32, oxygen has 16 times 4, we get 98. And so 2 zeros would be grams to moles. Accordingly, we have found the molar mass. Now we have to find the number of moles. The mole number. Respectively, we will divide the mass of sulfuric acid by the mass of mole. That would be 1960 grams to 98 grams in relation to the mole. And accordingly, grams and grams will be reduced, and the number of moles we get is 0.2, and we'll have that in moles. Now we need to find the concentration, but let's see, we have the volume and it is given in centimeters cubic, so we need to convert the volume of our solution into units of decimeters. To do that, we're going to divide 400 centimeters cubed, we divide by 1,000. It turns out that it will be 0.4 decimeters cubic. Well, now it won't be difficult to find the concentration. Concentration, which is expressed in moles, in relation to decimeters cubed, is the ratio respectively in moles. The sulfuric acid found, and in relation to, let's add so that we have the same accuracy in decimeters cubic, and accordingly we'll have that in 0.5 and in units of moles per decimeter cubic. That's it, we have our answer. And now let's solve the second problem, but in this problem I have made an element of complication. That is, it is a little bit different from the previous problem, although the calculation asks to make exactly the same concentration. What is unusual here? It is that I gave not the mass of the substance sodium chloride, but its number of particles. So the first thing we're going to do is find the number in moles, but we need to find the number in moles using a different formula. For sodium chloride, for this we'll use the formula number of particles divided by Avogadro's number. And that equals 1204 by 1023, and the Avogadro number we need to remember, and that will be 602 times 1023, respectively, a mole minus 1. And then in this case we can reduce here. And that would be 2 and respectively 2 moles. Now let's see what the volume is given in. The volume is given in centimeters cubed. Then we can necessarily translate the volume for this 800 centimeters cubic. We divide it by 1,000. And then we get 0.8 decimeters cubic. Now it shouldn't be too difficult to find the concentration. Concentration expressed in moles versus decimeters cubic meters. So let's do a final calculation. So 2 moles, well, let's bear in mind that we've got a number. The decimal point has to be the same, so let's make it 2 digits. So here we divide by the volume expressed in decimeters cubed, and this respectively will be equal to 2 whole 50, and the unit of measurement will be mole, divided by decimeters cubic. That's it. We have our answer. So I hope it is clear how to solve problems of this type. So we are already solving problems on solutions, taking into account the second type of concentration. If you have forgotten how to solve the previous problems, watch them, and in the next lesson we will work with problems expressed in percentages. The dissolved substance is taken as a percentage. These are also concentration problems. Goodbye.